Yeah, good problem. Today we have a division problem. X squared plus x over x squared minus x minus 6 divided by x squared minus 3x minus 4 divided by x squared minus x minus 6. So we have a lot happening right off the bat. So I have division of rational expressions. So right away we know we can't actually divide. So what we're going to do is we're going to end up multiplying by the reciprocal. So we're going to do that. Now you can change it right now. You don't necessarily have to. I'm going to hold off on changing it just because I want to talk about something regarding our potential solutions. So let's first off, let's just factor everything. Let's just start off by doing the fun factoring part where we're going to factor. So I'm not going to switch it just yet. I'm going to leave it alone for a second. I'm just going to go ahead and factor everything. So for my first fraction here, the top left, x squared plus x, I'm going to factor out an x. That's GCF. That's all I could take out. So then I'm going to be left with x plus 1. Taking out an x from there. On the bottom, I have a trinomial. I'm going to factor this. What I'm looking for here is I'm looking for two numbers that multiply to -6 and add up to -1. So that's going to be x minus 3, x plus 2, right? -3 times 2 is -6. -3 plus 2 is -1, okay? And I'm still on the original problem. I'm not changing anything just yet. And then on the top right, I have another trinomial. What I'm looking for here is I'm looking for two numbers that multiply to -4 and add up to -3. So two numbers that multiply -4, add up to -3. That's going to be -4 and +1. So it's going to be x minus 4 times x plus 1. Let's double check. -4 times 1 is -4. -4 plus 1 is -3. Cool. And then my final one, I'm looking for the exact same thing as the first one the first trinomial. So I'm just going to go ahead, it's the exact same problem, x squared minus x minus 6, and that factor to x minus 3, x plus 2. Here's why I held off on actually flipping it and change the multiplication, because I want to just look at the denominators here. In a rational expression problem, we can never have 0 in the original problem in the denominator or even the solution. So we do want to take a second and identify what are some x values that we cannot have in our final answer if we were going to go ahead and solve for x here, or just in terms of the domain. So I'd have x minus 3 equal to 0. I'd have x plus 2 equal to 0. And I think that's it, right? Yeah, because those are the only two because they're the exact same. So that means if I add 3 over, x cannot equal 3, and if I subtract 2 over, x cannot equal -2. So now that we've identified just what x cannot equal, let's move forward with the actual process. So I factored everything. Now what I was talking about before is we want to change this to multiplication and take the reciprocal of that second fraction. So I'm going to leave the first one the same, and I'm actually going to change this to just times like that, so we don't think that's like a multiplication or anything. So we're going to have x times x plus 1. The first fraction is not changing. The second one we are going to flip, and this is going to become x minus 3 times x plus 2 over x minus 4 times x plus 1. Now that I'm thinking of it, here's a note that I want to make. Before we change this to multiplication, like in this step right here, we have it written like this, there is absolutely no simplifying that can be made going across that division sign. Like if you had like an x plus 1 on the top left and then an x plus 1 on the bottom right, you cannot simplify that. Like if this was x plus 1 and then you had an x plus 1 down here, they can't cancel because this is division. You have to get to the multiplication step after you flip the reciprocal, and then if there is some simplifying you can do, that's when you begin that process. But as long as it's division, you cannot start cleaning things up. Now that we've changed it to multiplication, took the reciprocal, now we can move ahead with actually the simplification process. So what we're looking for here is same factors. So I have an x, a factor of x here. Do I have any just x's, multiples, x's, factors? No, nothing with just x. I have x minus 3, x plus 2, and so on. Nothing that can cancel. Next one, x plus 1. Do I have any x plus 1s here? Yes, I have an x plus 1 right here, x plus 1 right here. So those are going to cancel. Next one, x minus 3. I have an x minus 3 right here and an x minus 3 right here. Those are going to cancel. X plus 2, x plus 2. Those are going to cancel. So what's left over? After the dust settles, we're left with just this x on the top And then on the bottom, we're left with just x minus 4. So that would be my answer. Because everything else canceled out and we have no other simplifications to make, you absolutely 100% cannot do this. And I'm going to erase this immediately. Say that. X's do not cancel out here. Can't do that. While I'm actually talking about the solution, let's go back to when we changed this to multiplication. So in the original problem, we had just x minus 3 and x plus 2 as our denominators, and we identified that x cannot equal 3 and x cannot equal negative 2. Well, when we change it to multiplication, we want to do the same thing. So we're actually going to have some new values that x cannot equal if we go back to that step. So I'm going to say x minus 4 is equal to 0 because we have new values in the denominator. So we do want to account for that. So x cannot equal 4, because if I add 4 over to both sides, I'm going to get x cannot equal 4. Subtract 1, x cannot equal negative 1. So in our solution, we get x over x minus 4, keeping in mind that x cannot equal 4 because 4 minus 4 is 0. Now, these domain, this is not something that you need to worry about, but some teachers might want to see that. Some people are just like, you know what, that's not really what I'm looking for here. I want to make sure you know how to divide these rational expressions and just understand the domain, because if you are taking a college algebra class or a business calc class or even a calculus class, that's something that's really going to come into play. So just something to make sure you know about. But the main focus is just making sure we get to this solution here.